Well, hello. It is time to do Module 2 out of our Physical Science, Exploring Creation with Physical Science, 3rd edition. And I'm excited. We've got some new terms here. Solution. Solution is a homogeneous mixture made by dissolving one substance in another. That's pretty much like sweet tea, as far as I can tell. Homogeneous meaning you can't tell there's two things in it except by tasting it. You can't not by looking at it. You can't. Remember buying non-homogenized milk in Ohio, and they would have the milk on the bottom and the thick cream on the top, and that was non-homogenized. They should have called it heterogeneous. Well, heterogeneous, but heterogenized. Is that a word? Milk, because it was different. You could tell the two parts. So non-homogenized was just easier to say, I think. Just saying something. So solution is the mixture of two things, and it can be together or apart. Homogeneous is together. Apart is the heterogeneous. All right, we've got solute, and the substance in a solution that gets dissolved is the solute. And so we have here sugar, and that is the thing in our sweet tea that would get dissolved. That is your solute. The solvent is, oh no, am I getting this wrong? Substance in a solution that does the dissolving. That would be the hot water, because usually, yeah, I didn't get it wrong. Substance that does the dissolving. Then we have solid, liquid, and gases. So solid will be like this remote here, obviously solid. Liquid would be like my orange juice this morning, and gas would be let's see if I can figure on here. Amazing fart. Can you make us a mazy fart? It's like, sure. Always happy to oblige. Yay! Good job, Maisie. That was stinky. All right. So that's our gas. What else do we have? Density is the ratio of a substance's mass to its volume. So the mass, and I'm just not going to go any further on that because I can explain it better. So think of mass and volume making density, okay? And we have diffusion, or that's like the diffuser movement in gases and liquids. It spreads out the particles, tiny, just diffusing them into the air. Sometimes how it happens. All right, then we have this diagram where the tippy top we have matter, and matter can be broken down into two parts: pure substances and mixtures. Pure substances can be broken down into elements. Oh, can you see that? Elements and compounds. Compounds are just different kinds of atoms. Remember, elements are broken down into atoms, and compounds are different atoms attaching to each other. So, these are the elements, or atoms in an element. These are different atoms combining to make the compound. Okay? And so the difference between them is that this can be broken down into two different parts. It's not easy to do. It's not just like skimming the fat off of the milk in Ohio. This is more like we have to evaporate the water out of the sugar water to get the sugar back. It's really hard, but it can be done. Okay? Then over here in the mixture we have, as we talked before, the homogeneous and the heterogeneous mixtures. So as we talked before, combined milk, normal milk you buy in the store is homogeneous. Non-homogenized would be the same as heterogeneous. You can see the different parts in it. Just like when we did that experiment, and we had the oils and the different things in the layers. Heterogeneous. All right. Keep on looking. What else we've got to go through today? So all matter takes up space and has mass. It's really important to know. Number 4, I'm going through the study guide basically. Number 4 is, which of these substances is not an element? Water, hydrogen, aluminum, or iron? Water is not an element. That's the answer to that one. Number 5, all pure substances have a fixed composition. Compounds are pure substances that contain more than one type of atom that are in a fixed proportion. So if this is a sugar compound, all sugar compounds would look exactly like this. And that's why every granule of sugar tastes the same. The 3 common phases of matter used to group substances are solids, liquids, and gases. That's easy. Salty water is best classified as a mixture. Number 8, which of the following is not an example of a physical property? Melting point, reactivity, density, or hardness? Not an example of a physical property. Number 8, reactivity is a chemical property. So we can derive from that melting points and density and hardness are all physical properties. So not reactivity. That's a chemical property. A property metals have in common is that they conduct electricity. All metals do. Which action involves a chemical change? Making sweet tea, freezing water into ice cubes, shredding paper, or baking a cake. What do you think? I've always told you guys, when you do baking, you are doing chemistry. It's baking a cake is a chemical change. Evaporation and condensation are phase changes. What is the difference between an element and a compound? Well, a compound can be broken down into simpler substances. An element cannot. I think we looked at that right here, and I think we know exactly why that is. It already is as basic as it gets. Atoms with a T. What is... Oh, we just did that one. So here's a couple of grids. They want to basically have us go through and discern between physical properties and chemical properties. So we're going to kind of talk about which one's which. So if we can see it, it's probably a physical property. So red color, see it? Physical property, not a chemical one. Flammability. Well, I can see some flames when they come out, but whether or not something is flammable is actually a chemical property, or how flammable it is. Density. You can use your senses on that one and measure it. It is a physical property. Solubility, how soluble something is, how meltable it is into another liquid, is a physical property. Melting point. Melting point is a physical property. Odor, thank you, Maisie, is a physical property. Hardness, physical property. Oh, really? He's making noises over there. Whether it reacts with water to form a gas. What do you think? They say it's actually a chemical property. Whether something reacts with water to form a gas. And then malleability. As we talked before, what is malleability? It is the ability of a metal to bend and mold into the shape that you wish it to. So malleability. And then they compare physical change to chemical change. So those were properties. Now changes. Whether salt dissolves in water, would that be physical change or chemical change? It's physical change. The salt physically changes. A penny is cut in two. Boop. Physical change. An acid and a base react to form a salt, water, and heat. That would be a chemical change. Something's reacting there. Water is heated and turns to steam. That is a physical change. It went from liquid to gas form, basically. Diffused, and maybe, depending on how it did. Evaporated. It evaporated. All right. Copper reacts with moist air to form a patina. Ooh, new word for me. You hear the word react, chemical change. Ice melting. What do you think? Just a physical change. Milk curdling. Why does milk curdle? Well, I know I can make it curdle when I add an acid to it, like vinegar. So that would be a chemical change. It's reacting to something else. It's curdling. Volume of air decreases when the temperature decreases. That is just a physical change. No reaction going on there. All right. So breaking a compound down into its elements involves a chemical change. A compound and the elements that make it up are different substances. So breaking down a compound involves making new substances, which is a chemical change. All right, last one, viscosity. My favorite word of this whole chapter. Viscosity is a physical property because it can be measured or observed without changing the substance into a different substance. I like viscosity. Remember the molasses, or actually I think I used the example of honey when I was talking to you before. Honey is when it's cold, it is like you can barely get it to move. You turn the jar upside down, it's barely moving. And it can even over time change into like crystallize a little bit. But you just pop that into the microwave for 10-15 seconds and it is runny and the viscosity changes completely. It's very, very, very runny. And so the viscosity is how slow it would run down a plate or fast. So that is module 2. Lots of things to go over there. And so listen to this a few times and it'll be good. All right, have a good day.